Here we have a real-life application dealing with scientific notation. It says a supercomputer can compute 16 quadrillion calculations every second. And it says how many calculations are possible in 24 hours if it can compute this many per second. Well, that's already a mind-boggling number, but then when you do that every second for a whole day, it just gets astronomically big. So I think scientific notation is definitely appropriate here because we're dealing with such large, cumbersome numbers. So what we'll have to do is take this number times however many seconds there are in a day. So let's start by writing this in scientific notation. So this would be 1.6 because you'd have to write it to where only a ones digit is showing. And then we'd have to move this decimal place for 1.6 to the right. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 places to the right. So this will be 1.6 times 10 to the 16th power. And that's so much shorter and condensed and easier to work with. I will multiply this times however many seconds there are in a day. So we might need to do that calculation over here on the side somewhere. We have 24 hours in one day, but then there are, let's see, 60 minutes in 1 hour, and there are 60 seconds in 1 minute. And so here we've got the minutes units canceling and the hours units canceling. So 24 hours would be equivalent to this many seconds. So let's take 24 times 60 times 60. We'll do this on our calculator real quick. Take 24 times 60 times 60 more, and we'll get 86,400, but we can go ahead and write this in scientific notation as well. This would be 8.64 times 10 to the 1, 2, 3, 4. We'd have to move that decimal place right 4 places. So 8.64 times 10 to the 4th. That would be the same as 86,400. So really I have to multiply these two quantities together. This many calculations every second times this many seconds would give me the total number of calculations. So if you remember how to multiply in scientific notation, if you wanted to do this manually, you could take 1.6 times 8.64, that would be your leading number, times 10 to the 20th, because that's 10 to the 16th times 10 to the 4th, where you add the exponents. But I think I'm just going to let the calculator do all the work. So we could take this calculator and we can write 1.6 times 10. Actually, we don't even need the times 10. If you remember, the EE key takes care of the whole scientific notation. 1.6 times 10 to the, what was it, the 16th? And we'll take that quantity and multiply that by 8.64 times 10 to the 4th. So we'll have both of our numbers being multiplied. They're in scientific notation in the calculator. The EE notation represents the times 10 to the blank. Multiply it. It'll take care of our decimals and everything. It'll take care of our exponents. And so our final answer is 1.3824 times 10 to the 21st. So make sure to express this appropriately. Don't write this exactly like you see it, because your teacher or your instructor is not going to want to see an E in your answer. So we'd write 1.3824 is equals 1.3824, and we would actually write times 10 to the 21st power, because it says E21. So that's times 10 to the 21st power. So that's an astronomically big amount of calculations that our supercomputer can compute in a full day. So anyways, this is how we do word problems dealing with scientific notation. You write your large or small numbers in scientific notation and then multiply or divide or do whatever you need to do to get the appropriate answer.